Hello and welcome to Linear Approximation with Elliot Cohen. Today I'm going to teach you how to properly use linear approximation. We're going to start off with an example. Example number 1. Find the linear approximation to the given function at the given point. So we're given f of x is equal to 2 to the x at x is equal to 3. The first thing that we're going to want to do is we're going to want to provide point slope form. That would be y minus y1 is equal to m, which is the slope, times x minus x1. Then what I like to do is I like to provide f of x again, which is 2 to the x, so that now we can take the derivative of f of x. Derivative of f of x is f prime of x, which is equal to 2 to the x times ln of x. ln of 2. Then what we can do from there is we can plug in the given point, which is 3. So f prime of 3 is equal to 2 to the 3 times ln of 2. This we can simplify down to 8 times ln of 2. Now that we found the derivative, which is the slope at a given point, which is x is equal to, which is 8 times ln of 2, we can then plug that back in to point slope form. So now we can go y minus y1, which is 8, is equal to x times ln of 2, which is the slope, m, times x minus x1, which is 3. If we simplify that down to slope-intercept form, we get y is equal to x times 8 ln of 2 minus 24 ln of 2 plus 8. That is our linear approximation at the given function at the given point. Commonly missed mistakes that I've found is simplifying it down to slope-intercept form from point-slope form. Although the form doesn't matter too much, I find it easier when you want to end up graphing to use slope-intercept form, because now you have m and x differentiated. Let's try another example. Example number 2. Find the linear approximation of square root of 9.11, and the original function is f of x is equal to square root of x. So what we're trying to do is just find a linear approximation. An approximation would be square root of 9. Since x is 9.11, an approximate of x would be 9. Square root of 9 is also equal to 3. What we can do from there is we can now find the derivative of f of x, which is f prime of x, and that's equal to 1/2 times x minus, to the negative 1/2. That's the derivative of the original function. There we can simplify that down to a little bit. It's f prime of x is equal to 1 over x square root of, 1 over 2 square root of x. When we plug 9 in, we get that f prime of x, or f prime of 9, is equal to 1 over 6. This is our slope. This is our m. Now we can convert it into point slope form. And that would be y minus y1 is equal to m slope times x minus x1. Be y minus y1, which is 3, is equal to the slope, 1 over 6, times x minus 9. From there, now we can plug in our 9.11 into x. Since we're trying to find the linear approximation, we get y minus 3 is equal to 1/6 9.11 minus 9. Convert that to y minus 3 is equal to 1 over 6 times 0.11. Add 3 to both sides. You get y is equal to 1 over 6 times 0.11 plus 3. So y is approximately 3.08. So that can be translated to the square root of 9.11 is approximately 3.018, which is what we got as our y value. Some commonly missed mistakes is making sure that you understand that really the square root of 9.11 is approximately 3.018. When I first went through the problem, I got down to what the y value was approximately, but I didn't really understand what that meant. You can look at the question and you're really asking for the linear approximation of square root of 9.11. And when you plug it into a calculator, you get about 3.018. Another commonly missed mistake is not really knowing what this x value is. Since you're trying to find the difference between your original given x and the approximation x, which is 9, you're really just trying to find the difference in between it when you plug it back into intercept form. So you'll get 0.11 is the difference. That's why here it's really just the difference between 9.11 and 9. Hope you learned a lot. Until next time, bye.